All right, I wanted to talk about these 30, 60, 90 triangles and give you kind of an idea of what relationships we can create based on the short side, the long side, and the hypotenuse. So I'm going to switch over to this camera right here. I'm going to start with, we've got an equilateral triangle here. So I'm going to kind of build this idea, and you can see where the relationships come from. So in my equilateral triangle, all the sides are the same. I'm going to just kind of pick one. I'm going to say 8, 8, 8, 8. So all three sides are 8. It works out that in an equilateral triangle where all the sides are the same, it's also equiangular. So all the angles are the same. They all end up being 60 degrees, 60 degrees, and 60 degrees because they all add up to 180. Okay, so I've got my equilateral triangle. And the next step is I'm going to split that triangle in half. Like that. So I've split that triangle in half. And if I split that triangle in half, this part right here would have to be 4. Because the whole side is 8, and I split it in half. Half of 8 is 4. So that part right there, that's 4. This angle that I split in half here, well, half of 60 would be 30 degrees. And when I split this in half, this ends up being a right angle. So I'm going to redraw that top half of the triangle. So this is the top part there. I said this was 4. This is still 8. That really hasn't changed. That's still 8. This angle is still 60. And because I split the angle at the end here, this now is 30. So that's where we're getting the 30, 60, 90 triangle from. And one relationship we can see right away is that on the general triangle, on the general 30, 60, 90 triangle, 60, 30, there's a short side, there's a long side. When I say side, I should really be saying leg. There's a short leg, a long leg, and there's the hypotenuse. Hypotenuse, close enough. There we go. So those are the 3 sides of the triangle: short leg, long leg, hypotenuse. And the relationship between the short leg and the hypotenuse is that the short leg is always half of the hypotenuse. Always. And it's because of what we did over here. We split that side in half. And so no matter what, this short leg here is always going to be half of that hypotenuse because of what we did over here. So I'm going to write down here that the short side times 2, that's a 2, is always going to equal the hypotenuse. Forgive my handwriting. So that's the first relationship that we're looking at. If you know the short side, you can always find the hypotenuse by multiplying it by 2. If you know the hypotenuse, you can always find the short side by dividing it by 2. Now we got to talk about the long leg. So the long leg of that triangle, we're not going to go through where this comes from. If you use the Pythagorean theorem, remember the Pythagorean theorem said 8 squared equals 4 squared plus something squared. If you follow that and you take the square root and you do all that stuff, you end up getting that the long leg is going to be whatever this side is, 4, times the square root of 3. And it's always 3. It doesn't matter what this number is, doesn't matter what this number is. It's always the square root of 3. And to find the long leg, you always take whatever the short leg is, whatever this number is here, times the square root of 3. And I'm not going to write that as a decimal. I'm not going to plug that into a calculator because I don't care what that is as a decimal. The exact, precise, perfect answer is 4 root 3. 4 times the square root of 3. It's a crazy decimal that never ends, so we just leave it as 4 square root of 3. So if you know the short side, and you do times the square root of 3, and we're not actually going to put that in a calculator, we're just going to put the square root of 3 next to it here, times square root of 3. That will always equal the long side. All right, let's use that rule to answer this question here. So it says here that the short leg is 5, and sure enough, the hypotenuse is twice as big. Short times 2 equals hypotenuse. 5 times 2 equals 10. That works perfectly. If I want to know the long side, I'm going to take whatever the short leg is times the square root of 3. That'll give me the long leg. That's the answer you put, 5 root 3. That's it. That's where that came from. Let's look at number 5. Here we go. All right. So number 5 says we know the hypotenuse is 12, and we want the short leg. Well, if I know the hypotenuse and I want the short leg, since I'm kind of going backwards through this, instead of timesing by 2, I would divide by 2. And that's what we see here. 8 divided by 2 is 4. 12 divided by 2, there's the 12. 12 divided by 2, 6. So the relationship between the hypotenuse and the short leg is that the hypotenuse is twice as big as the short leg. The short leg is half of the hypotenuse. Look at one more, number 6. Here it is. This one says we have the hypotenuse is 12. We want the long leg. So I'm going to pull this back up. Let's see, if I want to know the long leg, that's what it's asking. How long is the long leg of that triangle? I need to know the short, because it's just short root 3 equals the long. I don't know the short. I know the hypotenuse. But if I know the hypotenuse is 12, the short leg has to be half as long as that. So the short leg must be 6. Once you know the short leg, put that square root of 3 on the end, and you've got the long leg. Oop. There it is, 6 root 3. So that's how you do these problems. You don't need a calculator. It's either half of something or twice, times 2 for the hypotenuse and the short leg. And for the long leg, you just tag the square root of 3 on the end. All right, so I'm going to let you finish up those questions and let me know if you have any problems.